So recapping on yesterday, and I'll take us in to show you why the intermediate axis theorem fits directly into Euler's rigid body problem using Leve. So the video I did yesterday, we left it here showing this is the axes crossing over, and I'm trying to understand the complexity of how that would physically work. And that this is what it looks like inside with its equatorial wave and the whirlpool, vacuum above, light below, meters minus cubed, seconds squared, c squared underneath, creating past, future, all the stuff that we've looked at previously. So all I'm doing now is taking this complexity and I'm going to use Leve to explain it. So what Leve does is he takes the sphere and he turns it into a cylinder by taking the poles out, splitting the poles out and assuming that they're flexible supports with a height of any height based on the volume of the sphere that you're replacing. Once you've got this idea, you realize that you can solve it using matrix calculus, as he explains in his 1915 paper. And so you then take this concept and you say, okay, well, let's squish this down until this is as thin as it will possibly go. How wide will this go when we do that? So it'll be its radius will be relative to its circumference when we squash it. If it's the Poisson's ratio of water that sets how compressible this is, it will be a perfect disk. And so we can analyze the disk in this way. The radius will be pi, and that will set what the radius is. You see, it's the circumference driving the radius. Because it's circumference driving radius, it's a perfect pi ratio, so the units of the circumference are pi squared. Yeah, because it's pi times pi is, yeah. So it'll be 2, you know what I mean. So what I'm saying is that the angular momentum here now can be analyzed using Leve. What does the angular momentum actually look like? And so this is that wave opened out to make so we can analyze it. So this is the width of this is as far as water can possibly be compressed, and then we're saying this is the thickness that we're left with. We're now going to split that into 6 load cases and analyze it using Leve. Leve comes up with these load cases, and I've added the 6th case and the sixth load case and the 6th position based on his AB5, showing the droplet. And so now you can see that this is the thickness of the meniscus. If we're saying we've compressed water and it still exists, but we can't compress it anymore, what we've got is the meniscus in between our fingers. It must exist. And so we've just split it to analyze it. And there it is. Now, if we go to the universal forces and we remove them, it makes it easier. Here's the strong force. The universe is spinning. It's got an XY axis. Yeah, end of. Here's the weak force. It's got an orbital axis as well. Now, whether that axis is based on this thing is also spinning at c, which it could, and it has a bit more momentum, or whether the spin force causes this to start to rotate, either way, this axis there's now force from these 2 axes in the middle that's continuous because the spin continues and the orbital force continues because it's a spin causing the orbital force. So we can go back to where we were and now remove the x and the y axis other than knowing they exist, knowing that they are forces. So we have our x-axis, which is our spin of the universe, and we've got our y-axis, which is the rotation of the universe, of mass. There's the mass of both is in motion. So at the very center, we can say we have this Leve's 2-dimensional shape to analyze. We know that we can analyze the wave as a load, the motion of its wave. We can split the meniscus into 6 to analyze it, so we know this is true. And then we just put it back to its nth thickness again, and we see the actions of what's happening. So you'll see that it's as this does a motion, the negative vacuum above, meters minus cubed above, seconds squared, c squared below, light. The resultant of forces is that as per the AB5 that I love, with the drop it appears between 2 and 3, and that is where the mass is expressed, not at the center, offset. And that represents the y-axis of this Z rotation. Okay, so this exists on its Z-axis. It's the same as the X-axis, apart from it's independent. And that because it's independent, it means then that the load is offset. It means it's tilted. So as this rotates, yeah, it's maintaining that tilt all the time. 137 arc seconds. There it is on the X-axis, just through the weight of its mass. See it? And then over this side, we know from Levy that there is a positive moment, an uplift at this point. And so what will happen is that the light under here will be pushed up. There is an updraft here, downdraft from load, updraft from light. This download is caused by this wobbling. Yeah, the YZ axis actually wobbles around the true Y-axis, creating a resultant of forces. There it is. So that it can be doing, as an exaggeration, as this spins around, it will do this. You get me? As it's turning, that's its motion. What we want is real stability. We want that thing nestled up there at 137 arc seconds, just nudged off the universal Y, matching what's happening here. If this mass here is too great, if gravity is too strong, caused by our behavior, get this, the conscious mass moment is there. If we are too weighty in our gravity, in the way that we live, this is too big. And that increases that to 137 and a bit. And so everything starts to go out of balance. It restores its balance by flipping over. It's just going to flip over. Look how unstable this is now. This wobbling, wobbling, wobbling. This is vacuum above. Like only vacuum above is keeping it going. Whack. It just does that occasionally. And then back again. And it's all, you can analyze this using Euler's stuff, the time dependency factor. I've brought it in here, but it's pi real. It's the golden ratio pi, 3.144, because it's motion. It's motion. Static pi is our drawing circles geometry. Motion pi is the golden ratio. Oh, well, I'm hoping that makes some sense, because it does to me, and I'm desperate for someone else to go, oh, well, yeah, that's true. You've discovered it. It's called The Principle. There's a video I found on YouTube, and it's about this guy supposedly debunking it says geocentrists tricked physicists, but it's not a trick. It's true. They built a model. It's called The Principle. And this guy's debunking it, and it's a nightmare of gaslighting. It's awful to watch. It's an educational video in its own right. But the principle is dead right. What's the principle? Well, it's the opposite of uncertainty. You use Heisenberg's uncertainty. This model uses the principle. What is the principle? That. Levy. Euler. Rigid body to elastic membrane. And it's solved. It's really, truly solved. All we need to do is put all the pieces in now, and all you clever people do that, and I can retire and get on with leading the planet out of this mess. Truly. Pirates on the bridge.